The octet rule tells us that all atoms want to be like the noble gases over in group 8 of the periodic table. They want to form a stable outer shell of 8 valence electrons. They're unstable and unhappy until they achieve this complete outer shell. But how does an atom with an incomplete outer shell get their 8 valence electrons? Well, one way is to gain or lose electrons, and when a neutrally charged atom gains or loses one or more electrons, it forms an ion, or a charged atom. Let's consider a sodium atom and how it might become an ion. Sodium has 11 protons. That's what makes it sodium, and therefore also has 11 electrons, giving it an overall neutral charge. We can see that 2 of these electrons fill shell 1, 8 of these electrons fill shell 2, and the 1 remaining electron is by itself in shell 3. Sodium is therefore really unhappy and wants to get rid of this last electron so that it has a stable outer shell of 8 electrons. We know that in real life atoms don't usually exist on their own, so enter another atom. We'll use fluorine as an example. Fluorine has 9 protons and 9 electrons. 2 of these electrons fill shell 1 and 7 of these electrons fill shell 2. And here we can see that fluorine has an empty seat available in its outer shell. This makes it just as unhappy as sodium. But there's a solution. Sodium will donate its unwanted electron to fluorine, giving both atoms full outer shells with 8 valence electrons and making both very happy. However, sodium now has 11 protons, but only 10 electrons. This turns it into an ion with a charge of +1. This positive ion is called a cation. The T in cation, which looks like a plus sign, can help us remember that cation means positive ion. Fluorine, on the other hand, now has 9 protons and 10 electrons, which turns it into an ion with a charge of -1. Because it has a negative charge, it's called an anion, which is a term for a negatively charged ion. These ions bond together and form an ionic compound called sodium fluoride. In another video, we'll discuss how to name these compounds and write their chemical formulae. But for now, let's have a look at a few other examples of atoms forming ions. Here we have a magnesium atom. We can see from the periodic table that magnesium has 12 protons and therefore 12 electrons. 2 of these electrons fill shell 1, 8 electrons fill shell 2, and 2 electrons fill shell 3. To become stable, magnesium would prefer that these 2 electrons went somewhere else so that it has a full outer shell of 8 valence electrons. Now let's consider oxygen, which has 8 protons and 8 electrons. 2 electrons fill shell 1 and 6 electrons fill shell 2. This means that oxygen has 2 spare seats in its outer shell. So when magnesium meets oxygen, it suits both atoms for magnesium to give away 2 electrons to oxygen. Magnesium will then have 12 protons, but only 10 electrons, giving it an overall charge of +2. It has formed a positively charged ion, which we know is a cation, and oxygen will have 8 protons and 10 electrons, giving it an overall charge of -2. It has formed a negatively charged ion, an anion. These 2 ions will bond together into an ionic compound called magnesium oxide. Now it's your turn. What would happen if aluminium, element number 13 on the periodic table, bonded with phosphorus, element number 15? Which would become a cation, which would become an anion? And what would their charges be? Pause the video here and have a go at coming up with an answer. Here's our answer. Aluminium, element number 13, has 13 protons and 13 electrons. 2 of these electrons fill shell 1, 8 electrons fill shell 2, and 3 electrons fill shell 3. So this aluminium atom does not have 8 valence electrons, it only has 3. Phosphorus, on the other hand, has 15 protons and 15 electrons. 2 electrons fill shell 1, 8 electrons fill shell 2, and 5 electrons fill shell 3. So phosphorus has 5 valence electrons. So because of the octet rule, aluminium wants to give away 3 electrons and phosphorus wants to gain 3 electrons. And very conveniently, it can get these electrons from aluminium. So aluminium now has 13 protons and 10 electrons. This makes it a cation with a charge of +3. And phosphorus has 15 protons and 18 electrons. This makes it an anion with a charge of -3. And these 2 atoms bond together to form an ionic compound called aluminium phosphide. Well done if you figured that out. Now you may have noticed a pattern occurring. Let's look at our periodic table. we've figured out that sodium, which is in group 1, forms a cation with charge +1. Magnesium, which is in group 2, forms a cation with charge +2. Aluminium, which is in group 3, forms a cation with charge +3. And phosphorus, which is in group 5, forms an anion with charge -3. Oxygen in group 6 forms an anion with charge -2, and fluorine in group 7 forms a charge of -1. So you can see that if we know what group an atom is in, we know what kind of ion it will form. Nice and easy. Group 4 elements, which we haven't mentioned, will either gain or lose electrons to form ions with either plus or -4. And group 8 elements are the noble gases, which already have a stable outer shell of 8 valence electrons, so they won't form ions. What would happen, for instance, if sodium met oxygen? We already know that sodium will form a cation with a charge of +1, and oxygen will form an anion with a charge of -2. So a neutral sodium atom wants 1 electron given away to become more stable, but a neutral oxygen atom wants to take 2 electrons. How does that work? What's going to happen? Well, atoms rarely exist alone in real life. They're just too tiny. Where you find 1 sodium atom, you'll find more. So oxygen says to sodium, bring a friend, and enter a second sodium atom. Each of these sodium atoms give 1 electron to oxygen. So oxygen gets 2 electrons, and each of the sodium atoms give away 1 electron, and everyone's happy. The resulting compound is therefore made of 2 sodium atoms and 1 oxygen atom, which we write as Na2O. Remember that we'll talk more about how to write and name ionic compounds in another video. For now, we're just focusing on understanding how ions form. Another example is magnesium and chlorine. Magnesium in group 2 will form a cation with a charge of +2, and chlorine in group 7 will form an anion with a charge of -1. So magnesium wants to give away 2 electrons, and chlorine has 1 spare seat in its outer shell and wants to gain 1 electron. So in this case, chlorine will bring a friend. One of magnesium's unwanted electrons will go to 1 chlorine atom, and the other electron will go to the other chlorine atom. This forms an ionic compound with 1 magnesium atom and 2 chlorine atoms, written as MgCl2. So to recap, the octet rule tells us that atoms want to form a stable outer shell of 8 valence electrons. An ion is a charged atom, a cation is a positive ion, and an anion is a negatively charged ion. We can use the group numbers on the periodic table to predict the charges of ions, and ionic compounds form when anions and cations bond. Remember that you can re-watch this video as many times as you want. Enjoy.